Hi, in this video we'll do a practice on plotting the graph with error bars and also max mean line. So the question have already given you the data already, and in the unit of milli and millivolt, the uncertainty of current will be plus or minus 4 mA, which you need to use this to draw the length of the error bar later on. For the voltage, I don't think they have mentioned it, so I guess we can assume there's no uncertainty here. In the practical situation, it depends. If whatever measurement you do, there must be some absolute uncertainty. But if you are having the uncertainty that is not significant enough to be visible on the graph, then you can simply say it in your IA. And the graph you need to plot is current against voltage. So I should put on y-axis the I in the unit of mA and voltage in the unit of mV. Okay, and then next thing that we should do is to decide the range of the axis. So for V, we go from 0.1 all the way to 0.4. So let's do 0 here, and I think 1, 2, 3, 4. I think that's what I would do. 0.1, 0.2, 0.3, and 0.4. Okay, and if you have a program to do this, of course, it's much easier. And for I, it go up to the range of 90. So I think there should be enough for 10 as interval. Let's see. Okay, good. So for now, then I would need to plot the data, the coordinate, as if what you do in the previous years in IGCSE 2. So let's just do it. 26. So here, and then 48. 65. 90. Right, 0.4, yes. Okay, cool. So now is the part where you have to use what you learned in the previous video in IB physics, which is about the error bar. So let me use the blue color to show it. So plus or minus 4. That is because this grid is 2, so 2 grid up and down. Okay, so 2 grid and 2 grid. Okay. Okay, I didn't draw very perfectly, but I hope you can understand that. Okay, it was 65, so it'll be barely touching it. So it's 69 and 61. And for this one, it will be 94 and 86. Okay, so now you got all 4 error bars on the coordinate. Again, for the x1, like horizontal one, since it's not mentioned, so I assume it's too small to be mentioned. Alright, so for the line of best fit, then of course you want to fit the straight line because they look like a straight line, and also from your physics knowledge as well, the voltage and current should be having a linear relationship. Alright, but then again, since this doesn't tell you the range, because the question eventually wants you to deduce whether current is proportional to voltage. In order to check that, what you have to do is you will need to rely on the maximum and minimum line to see whether or not it covers the origin. So like what I mentioned in the previous video. Okay, and here are 2 more lines, which let me do the maximum first. And we will do the top of the last data point and also the bottom of the first data point, and let's just see if they pass through all the other data point, and I think the answer is yes, right? Or barely. I actually think if I really want to be strict, and here it actually doesn't pass through because this is supposed to be 69, not 70. So I actually should adjust this to be more gentle, unfortunately. Probably, yeah, something like this. Okay, I think this is the best we can get for maximum line. For minimum line, then we do basically the opposite. So align the top of the first data and then adjust with the bottom of the last data. Alright, and the middle part, yes, it's all good. Alright, and then we shall extend this through the y-axis. Okay, we are still all good here. And then the green one should be something like this, because I'm still looking at this part. Okay, so yeah, I think that's something we have to keep. Okay, here maximum point, and then here, can we take more precisely? Is that okay? Not quite, so I think we'll compromise again. Okay, yeah, I think that's the one that we can do. Okay, so in this case, then you can see the area that we cover by the two maximum and minimum line will have an area of this, basically. Of course, I draw over the space right here. Okay, so all these will be possible data that you can have. Most importantly is here, right, that it cover the origin. So that is to say the current is really proportional to voltage, because when you say proportional, it is saying that y equal to kx. Okay, there's no plus c, or you may say plus c is gonna be 0. It's different idea when you say y equal to mx. M and k are both the same, just a slope, plus c, and then this c is non-zero. Therefore, what you can say about this kind of equation, you can only say they are linear only. Okay, and linear is not the same as proportional. Here is referring to directly proportional. Actually, there's something called inversely proportional, I'm sure you know. So directly proportional is not the same as linear because of the difference of the y-intercept. So whether or not they pass through the origin or not.